In this next section, we're always going to be rotating around the y-axis, so we just need to remember our formula for rotating around the y-axis. It's the integral of pi x squared dy. So in order to use this formula, we're going to have to find an expression for x in terms of y. So if we take our expression here, we can rearrange this to get y plus 1 over 4 equals natural log of x. So we can get an expression for x by doing e to the power of both sides. So we're going to get x equals e to the power of y plus 1 over 4. Now in our formula we want x squared, so we might as well over here square x to find an expression for x squared. So we're going to have e to the y plus 1 over 4 squared. Now remember, with these powers we're going to times them together. So we're going to end up with e to the power of, if we times this fraction by 2, we're going to have y plus 1 over 2. So we can substitute that in. I'm going to take the pi outside of the integral, and we're going to have x squared is y plus 1 over 2. And at this point I'm going to put in my limits. I'm integrating from y equals 0 up to y equals 4. So we'll do a formal method with substitution, and we'll look at a quicker way of integrating this. So you could write that as e to the power of a half y plus a half. If we just split this up into two fractions, split the power up into two fractions. And then if you wanted to use a formal method, you could use a substitution. So you could let u equal a half y plus a half, so that du by dy equals a half. And with the substitution method, we want to change it from a dy integral into a du integral. So if we rearrange this, we'll get dy equals 2 du. So we're going to have pi integral. Now I'm not actually going to change the limit, so I'm just going to leave it as y limits for now. Or the alternative method is you could change the limits, but you'll see why I'm not going to in a second. So we're going to have e to the u, and then we're going to replace dy with 2 du. Okay, so I'm going to take the 2 outside the integral, and when I integrate e to the u, with respect to u, we're just going to get e to the u. So we're going to have 2 pi, and then when we integrate it, we're going to have e to the u. But u is actually equal to a half y plus a half. So we're going to have a half y plus a half. So that's why I didn't change my limits, because I've just gone back into a function in terms of y, so I can sub in the y limits of y equals 4 up to y equals 0. The quick way of doing this without a formal substitution would just be to realise that we've got a function, e to the power of, and inside the power we've got a linear function of y. So we could integrate it as if it was e to the u, which would just be e to the half y plus a half, stays the same. But we'd need to divide by the derivative of the inside function. So divide by the derivative of this linear function of y. The derivative is a half. When we divide by a half, we'd end up with 2. And then finally, we can just substitute in these limits. So we're going to have 2 pi times by, sub in the top limit, and we'd get e to the power of 5 over 2. And subtract, sub in the lower limit, we're going to have e to the power of a half. So we want it in this form, and notice that they've taken out root e, which is e to the power of a half, as a factor. So we've got the 2 pi out already, so let's take out an e to the power of a half. And then we're going to have e to the power of, well, what do we need to times e to the power of a half by to get e to the power of 5 over 2? Whatever power goes here, we're going to add to a half to get 5 over 2. So that must be 2. And minus What do you times e to the half by to get e to the half? Just 1. And you could double check that if you multiply that out, you do get that expression there. So we're going to have 2 pi, and then they wrote e to the power of a half as root e. And that's what we wanted to show.